Okay, the one last concept that we need to talk about is called polarization. And you maybe have heard of it if you are into buying nice, expensive sunglasses, because there are sunglasses that are polarized. And we'll talk about how that connects to this in a few minutes. So, if you remember, an electromagnetic wave is a transverse wave. And so we're going right back to that very first day. A transverse wave is a wave that travels in one direction while its molecules that it's traveling through vibrate perpendicular. So we always think of our molecules vibrating up and down, and that is definitely perpendicular to the direction of the wave is traveling. But imagine that the wave is coming out of the page here. Then the molecules could be vibrating up and down, but they could also be vibrating this way, and that would still be perpendicular to a wave coming out of the page towards you. They could be vibrating in this direction or in this direction. Really, they could be vibrating in any direction in the plane of the paper, and that would still be perpendicular to the wave coming out of the page. Okay? And in truth, that's exactly what's happening in an electromagnetic wave. And the light is vibrating in all the possible directions. Okay? While it's traveling then out of the page. So we could take a piece of paper that has a slit in it, and we could put that slit in front of the way all the possible directions that the light is traveling. Now, how many hands do I have? Okay, so imagine here's the light traveling in all directions. Now if I put the slit in front of it, only the part of the beam that's traveling, vibrating in the direction of the slit would be able to come through. And so the slit is going to make our beam dimmer, right? It's going to block some of the light out. Now, and what we get then is all vibrating in the same direction, and that's what polarization is. So polarization is when one blocks all the different directions of vibration except for one. And so sunglasses are polarized, just the expensive ones, not the dollar store or Walmart ones, but you can buy polarized sunglasses that let only the light vibrating in the same direction of motion through. If I took a second slit, and maybe the easiest thing to do instead of me trying to do it on this, let me show you in the picture, if I can get my pen out. Okay, so here's the light beam coming. Here's the light beam coming, vibrating in all directions. So I put my polarizing filter in front of it, could be your sunglass lens, and the only thing that comes through then is the one direction of vibration that matches the slit. Okay? If I take a second filter then and turn it in the opposite direction, now all the light will get blocked. And the second filter is the way we can tell if the light is polarized, right? I could turn that filter around up the same way, and this one beam would still come through, but then when I turn it back, it will block out all the light, so there'll be darkness here. So if you do have sunglasses that are polarized, you could always pop one of the lenses out and rotate it in front of the other one, and you should see that it'll block all the light. Okay? Now, why is this handy? Or why do we care? Well, one of the reasons we care is that sometimes light gets naturally polarized. Light that strikes water or light that strikes snow reflects off polarized. That's why we get that glare off the water and off the snow. And it's why people who are skiers do buy expensive goggles to try to cut down the glare. The light from the sun can still come in, but you want to block the glare off the snow so you don't get blinded. And the same with the water. There are some animals that are sensitive to polarized light. We know that bees are. I don't know how we know. I don't know who thought of checking. I'm not even sure how they checked, and I really don't know why they want to know. But we know that bees are sensitive to polarized light. I don't know, maybe they make more honey when they're exposed to polarized light. But for humans, we can't tell if light is polarized or not. So if you go and buy a pair of sunglasses from a buddy on the street with a trench coat and all those glasses inside, can you tell I lived in New York City? And he's saying, oh, they're polarized. You would have no way of knowing unless you happen to have a polarized filter, or unless you pop the lenses out and turn them, turn them and to see if they, like at some point as you turn them, one point you should be able to see light, and then as you turn, you should have them opposite each other, and it should block all the light out. When you buy cheaper sunglasses, they're not polarized, they're just tinted. Okay, and so they wouldn't block the glare any more than they would block any other light. Polarization is actually evidence that light is a transverse wave, because only transverse waves can be polarized. And so because light can be polarized, we know it's transverse. Sound cannot be polarized, so it isn't. And then there's a last sheet in the notes that we put up on Teams for you, or sent to you. And it just shows the idea of polarized light. So here, flashlight, the slits are going one way, so one strand of light comes through. If you keep the slits the same way, the second filter the same way, the same light comes through. But if you turn that filter around so the slits are opposite, nothing comes through. And it's like trying to send a wave on a rope through a thing with slats in it, with openings in it, right? If the two openings are in the same direction, the wave will go through. But if you turn one of them around, it blocks the wave. Okay, so that is polarization, and that is the end of the Physics 11 course.